I'm Charles Hummel. I am Editor-in-Chief at Container Solutions. My guest today is Liz Rice, who will be co-presenting our first webinar of 2022, which is on eBPF and Cilium. Liz is the Chief Open Source Officer at Isovalent and is the Chair of the Technical Oversight Committee at the CNCF. Liz, welcome to the show.
Hi, thanks for having me.
So what are you currently working on?
So as we record, we are just coming up to a new release of Cilium, which is 1.11, and there's going to be some good new features in that. And we are also opening up a beta program for the service mesh, using Cilium as a service mesh data plane. So there's actually quite a lot of exciting things going on in the world of Cilium. And at the same time, I'm also working on CNCF things in my TOC role.
Excellent.
So life is busy.
Always good, always good. So what's the goal for the webinar that you're doing for us in January?
So I have been really excited about eBPF, which is the technology that Cilium is based on. I've been excited about that for a few years now, and I think it's a very important transformational technology for tooling in the cloud native world. And I would love to just share why I'm so excited about it as a technology and as a platform, why I think it's so important for this next generation of tooling for things like networking. eBPF, the P and the F stand for packet filtering. So there's been a networking element to it for a long time.
Right.
But it's also really powerful for observability tooling. We're increasingly seeing it used for security tooling. So it has huge potential, and I really want to share that with the audience.
Fantastic. So who is the webinar for? Who do you have in mind as the sort of audience for it?
So I think if you're in the world of cloud native, and you are familiar with, things like Kubernetes, you're going to hear buzzwords like eBPF. You might have heard of Cilium. It would be, what we're trying to do here is give you that kind of grounding in the technology, so you can understand the differentiators, the reasons why, because of its use of eBPF, Cilium is such an efficient networking data plane. So I think if you're in a platform team, for example, if you're looking for ways to improve the performance of your network, perhaps introduce new observability tools, perhaps you have interest in things like the capabilities of service mesh, but you're not quite sure where to start. All of these things relate to Cilium and the broader world of eBPF. So I hope we'll be able to share some pointers and get people excited about the capabilities here.
Excellent, excellent. So you've touched on this a bit, but what is it that eBPF allows us to do?
Fundamentally, eBPF allows us to write custom programs that we can run in the kernel, and we can load those programs dynamically. And that means we can change the behavior of the kernel in real time. And those changes of behavior can be functional changes, like changing where we send network packets, or they can be more instrumentation based, like keeping track of events and metrics and conveying that information to user space.
And I guess there are kind of two slightly separate audiences for this. So you've got people who are writing custom code in C or whatever as hooks to run in the Linux kernel. But there's presumably also a bunch of people that will use things written for eBPF that are kind of more like end users rather than kernel level programmers. Is that...
Absolutely. I mean, if we think about most organizations, if you're a Google or a Netflix, you probably do have people who are also kernel maintainers, but most organizations don't. Most developers work purely in user space. So I think, the majority of people won't write their own custom eBPF code, but it's helpful, I think, to understand the concepts and understand what kernel programmers are doing when they write eBPF code, because it gives you a real insight into why these eBPF-based tools are so efficient and performant and able to observe everything on a system without needing changes in user space. So it kind of almost sounds like magic sometimes. And I never like it when technology sounds like magic. I always want to turn magic into something a bit more concrete that people can get a mental model for.
Yes, yes. And then where does Cilium and eBPF kind of meet? What's the sort of intersection point there?
That's actually a really great question, because it's quite complex. So the founders of the Cilium project were also instrumental in the development of eBPF, and there's a lot of overlap between the people who are maintaining eBPF technology in the Linux kernel and who are also project.
Right.
So particularly in that kind of networking behavior, if we want to introduce new features in the Cilium project, quite often that also requires an upstream change in the kernel. So there's definitely a continuum of work there between kernel contributions and Cilium project and kind of functionality.
Could you give us a sense of what are the components of the Cilium project?
So there is an agent that runs on every node that acts as a Kubernetes CNI, a network interface. And what it's doing is installing eBPF programs for connectivity as pods are being created on that node. There's also a component called Hubble, which provides observability. So it's an optional component that you can add to see the network flows that are passing through the connectivity that Cilium has wired up. There's also a UI that you can use to visualize that Hubble flow information. So those are the main component pieces. In terms of functionality, it's offering Kubernetes connectivity. It's also used with some organizations use it standalone as a load balancer, as a performant load balancer outside of the Kubernetes world.
Anything I've missed? Anything else you'd like to add?
I'll also mention that I'll be joined by my colleague, Christopher Luciano, who's going to give us some, I'm pretty sure he's going to show some demonstrations of Cilium. I'm going to concentrate on the eBPF technology. He's going to focus on what Cilium can do for you. And I hope we're going to be able to show lots of live demos and make things really concrete for the audience.
That's fantastic. Liz, thank you very much indeed for doing that.
Thank you for having me.